Hello. Now let's solve this problem. The statement says that if for a two-dimensional potential flow, the velocity potential is given by phi is equal to x 2y minus 1. So first of all, let us write down what we know as the formulas. Okay. So we know that u, which is the velocity component at the x direction, right? And it can be written as negative d phi dx. V is equal to negative d phi dy and w is equal to negative d phi dz. Okay, so x along the x direction the velocity component will be u. For y direction the velocity component is v. For z direction the velocity component is w. And phi, or the potential function, is a function. If you do a derivation of this with respect to x direction, you will get the velocity component at the u direction, and you can derive, or you can have a definition of each of them like this. Okay, and this is a potential function, and it is possible for 2D and 3D both cases. If you just consider these two equations, it will be a 2D flow, and if you consider W as well, you will get a 3D flow. And we have already talked about the potential function. And what about the psi or stream function? In case of a stream function, our equation is, you can write it like this, that u is equal to negative d psi divided by dy. Okay, see, if you do a derivation of this psi function, which is a stream function, if you do a derivation with respect to the y-axis or the y direction, you get the velocity component at the x direction, right? In the same way, you can say that v is going to be equal to d psi dx. And one thing to note here, that this negative sign will be only in one case, like in this u, it will be negative d psi dy, or in v, it will not be applicable in both of the equations. And the stream function is only applicable for the 2D flows, two-dimensional flows. It's not applicable for the three-dimensional flows. Okay, and using the equation now, and the equation which we are given now, we are going to figure out the value of the stream function. Okay, now let's get started with the solution. So let me just separate it, and these are the formulas that you just need to know. And if you know these formulas, you can very easily figure out the solutions of different problems regarding this potential flow or the stream function, such that. So now let's write down what we are given here, and we will show the solution step by step. Given phi, the potential function is x y minus 1, you can write it like this, 2xy minus x, right? I've just simplified it a bit so that it becomes easier for me to do the derivations, right? Now you know that u is the velocity component along the x direction, right? U is equal to negative d psi dx, and it will become equal to minus ddx, and psi is 2xy minus x. And if you do the derivation, you will see that you will find minus 2y plus 1, and it will give you 1 minus 2y. In the same way, if you want to find the value of the velocity at the y direction, which is v is equal to what? Minus d psi dy. You were absolutely right. So now you write minus d dy 2xy minus x. You will get only minus 2x from here if you do the derivation here, right? Now that we have already got the value of u and v, we can now proceed for the points, right? At the point value is given as 4 comma 5. It means 4 is the value of x, and 5 is the value of y, right? So you just can put the values here in place of u, as you have already figured out the value of u is 1 minus 2y. So 1 minus 2 into 5, the value of y, and 1 minus 10, you will be left with minus 9, right? Minus 9 units per second. So this is the value of u, which is the velocity component at the x direction. If you in the same way want to find the value of v, which is minus 2x, so minus 2 into 4, and you will be getting minus 8 units per second. Both of the values are actually negative, right? So what we can do now is we can see that velocity at p is equal to negative 9i negative 8j, right? As I is the unit vector along the x direction and j is the unit vector along the y direction. So now we can say, or you can say that, or resultant velocity at p, that will become equal to, right? If you want to find the value from a velocity field, if you want to find the value from a vector field, how you do is you just need to take the coefficient of I and square it. You need to, and plus take the coefficient of j and do a square. And if you had something like this, plus suppose if you have something like 9 k is the unit vector along the z direction, right? So you should have taken 9 square, but as you don't have anything like this, you are not going to take something like this, right? So you will keep it as it is. Okay, so this is the value. If you just do some calculation, 9 square means 81 and 8 square means 64. So we are going to be getting 12.04 units per second, right? So this is the resultant velocity for the velocity components of u and v, and as this is a two-dimensional flow, so there will be a velocity along the y direction and the x direction. So you will be getting a resultant which is found like this. So you can also consider the Pythagoras theorem while getting this, right? So we have already found the velocity at the point, and now we need to determine the value of the stream function at the point. So before finding the value of the stream function at point P, we need to find the equation of the stream function. So let's check how we can get the equation for the stream function. You can observe one thing here, that you have already figured out the value of u and v, right? So as you have already the value of u and v, by using these two equations, you can figure out the value of the stream functions, right? And for a steady flow, the stream function and the potential functions, they will actually be coinciding. So there will be no issues. This value of u is found from using the potential function, right? So you can use it here, no problem, as both of them are two-dimensional flows, right? So now you can just do this calculation that we are actually now trying to figure out the value of the stream function. So I will write value of the stream function at p of the which is 4 comma 5, right? How we can do this? I have already shown you that d psi dy will be equal to negative of u, right? Because the differentiation with respect to x of this stream function will give you the velocity component at the x direction. If you do the derivation of y with respect to y, you will get in the other direction, right? In the same way, if I want to write it like this, that if you just write it d psi dx, you may say me that what is the answer? D psi dx, it is going to be v, right? If you have put negative sign here, you don't need to put it here, okay? Only in one place you will get this. But in case of the potential function, you can notice that the negative sign is in front of in front of every functions, right? So now we are just going to put the value of u here. You can understand the value of u is going to be what? Negative sign at its place. U is 1 minus 2y. If you see from here, you have found the value of u. U is 1 minus 2y, right? So u is 1 minus 2y. So the negative sign will make it 2y minus 1. And this is my equation 1. And what about v? V is negative 2x, and this is my equation number All right, just mark it like this too. So we have already found the value of d psi dy as 2y minus 1 and d psi dx as minus 2x. Now what we can do, we can simply integrate the equation number 1 with respect to y. Let's see how we can just solve the value for y. Integrating equation number 1 with respect to y. As you can see that there is no x term, I'm just going to simply integrate it with respect to y, and it will be making it very easy for me. See, if I just if I can remove the partial derivative sign. As you can see, we have already only one variable, that is y. So I can say that d psi is equal to, I am just transferring this to the right hand side. Okay, so d psi will be equal to 2y minus 1 dy and integration the both sides. So integration of a lot of small d psi will give me psi, right? And integration of 2y minus 1 with respect to dy will give me 2 y square upon 2 minus y, right? Plus a constant of integration will come into the play into the equation, and that will be c1. And c1, this c1, you can see that this c1 is a function of x, because you have integrated with respect to y. So you will get a function of x when you will uh, find the constant of the integration. Okay, so you can further simplify it writing like this. 2 will be gone, so you will find y square minus y plus c1. So congratulations, you have found the value of the psi, which is the stream function, right? We have found the equation for the stream function. So but we are not aware about the value of this c1, which is the constant. So we need to find this value of the constant. So how we can do this? Let's check this. Let's take a look at this equation, d psi dx. Okay, d psi dx is giving you negative 2x. Okay, suppose this is my star equation. This is my star equation. From this star equation, I can get what? If I just do a derivation, do a differentiation with respect to x, like d psi dx. I'm doing a differentiation of this, and I will get differentiation of y with respect to x is 0. In this case also 0. So 0 minus 0 plus with respect to x, right? So from here you can write d psi dx. From here you can see that d psi dx is equal to negative 2x. So you can put the value of negative 2x here, and you will get over dx. So from here you can very easily find the value of c1. How? Let's check. You can again change this tau, I mean this partial derivative sign, into the complete derivative sign. That will be capital D, small d, right? So we can write it like this, dc1. Okay, dc1 will be equal to negative 2x dx, and if there is integration in both of the sides, integration of dc1 will simply give me c1, right? And it will be equal to negative x square upon 2, here plus 2, so 2 will get cancelled, and I will be only left with negative x square. So from here I have found the value of c1 as negative x square, right? And I can very easily find this, use this value here in star. Okay, so from star I get psi is equal to y square minus y minus x square. I have just put the value of c1, which is negative x square. Are you done? You have found the stream function, but you didn't find the value at the point p 4 comma 5, right? You can say 4 comma 5 at point p 4 comma 5 you have to find the value of this stream function. So for this you will have to put x equal to 4 and y equal to 5 in order to find the value p 4 comma 5. Okay, so for that, at p 4 comma 5 I can get what? Psi will be equal to y square means 5 square minus 5 minus 4 square. So this will become 25 minus 5 minus 16, and it will give me 20 minus 16, that is 4 units. Okay, that means we ended up figuring out the value for psi, which is the stream function, which is 4 units, right? So this is my answer. And the previous value, this one was also one of our answers, because in this question we had two parts. Okay, so in this question we were given a value of a potential function for a two-dimensional potential flow. So we need to figure out the velocity of the point p 4,5 and also the value of the stream function at the point. So we have shown all the equations that you need to follow, that you need to know. These equations are for the potential flow and this is for the stream function. And we can compare this equation from this potential function. We can find the value of u and v, and then at the point 4,5 we can just simply put the values, and very easily we can just calculate the value for u and v, and we have just then figured out the value for the resultant velocity. Then as we are required to figure out the value for the stream function at p, 4,5, we can use the value of u and v, and we can use these equations. And then what we have done is we just integrated this equation number 1 with respect to y to get a function which is having a constant of integration, and that is a function of x. So then we figured out like this, that from star equation, this equation, we did a differentiation with respect to x. Then we figured out the value from here. We put this value here, and then we got the value for c1, and we have just put this value in this star equation in place of the c1 minus x squared. So this is your stream function. This function, you can see this is the stream function, and at the point which is given in the question, we have figured out the value in numerical numbers, right? That is 4 units. So as we are done with this problem, now I'm going to show you another problem. This problem. In this problem, you are given a value of u and v, and the first question is the flow possible or not, right? So let us just start writing the solution. Okay, so we are already given the value of the velocities, right? In unlike the other case, the first place we had a function, potential function. It can also be a stream function, no problem. Whether you are given a potential function or a stream function, you can certainly get the value for your u and v, right? And then you can use it for figuring out the other function which is not given. You just need to remember these equations, and you can also visualize it, right? Now let's get started with this. We are already given the value of u and v, and we are not given any function, because if we had any function like phi, we can very easily find out the value for u and v from this function. Or you can, if you are given a function of psi, then from this equation you can also find u and v, right? Because if you just do this d psi dy, you will get negative u, right? If you just do this, if you just do a differentiation of that function with respect to x, you are going to get v, right? So this is what I am just talking about. Okay, so now let's get started with this problem. As we are already having u and v, first question is the flow possible or not. So for figuring out if the flow is possible or not for an incompressible flow, we know, okay, just let me write it. For incompressible flow, du dx plus dv dy is equal to 0. This is a condition. This is what? Condition for possibility of flow. For possibility of, that means if you do a partial derivation of this u with respect to x, and then add it with the partial derivation of this v with respect to y, and if the summation of these two are giving you 0, that means it is a flow which is possible. Okay, so now let's see how we can do this. First, let's figure out the value for du dx. What is it going to be? Dx of u is given as 2xy, right? So what is it going to be? It is going to be 2y. What about du dy dy of v, right? Sorry, this is v. dy of v, it is a square plus x square minus y square. So you are going to get square will be 0. It is also going to be 0. So minus 2y. Now that means du dx plus dv dy is equal to 2y minus 2y is equal to 0. That means this flow is possible. Flow is possible. It means if you are given u and v, or even if you are given any function, you can write for a function like a stream function or any potential function, you can figure out the value of u and v. And if you just put this u and v in this equation, du dx plus dv dy is equal to, and it is becoming equal to 0, right? If it is satisfying this equation, then you can certainly say that your flow is physically possible, right? So this is the main idea behind the solution of this problem. This is the part 1. And now we need to obtain phi. We have already done a similar problem in the previous case, but in this case it is a little different in the sense that we need to just do some other approach. I will just show you how we can do this. You can also give it a try with yourself, if you can figure it out or not, because we are already given u and v. So now just let's put it in the equation of psi, right? So we already know we need to figure out what is the function of psi, right? So for that we already know that u is equal to what? Say me, d psi d y, right? And it is negative you can put, and v is equal to what? D psi d x, right? So this is the equation. These are the set of equations you can use, right? So from, I will write it like this. Just give it, I will write it like this. Okay, from u is what? 2xy. If I put this value in this equation, what I am going to get is d psi dy is equal to 2xy, right? I already had told you that you can put this negative sign here or here. In both the cases, it is going to be no problem, right? I am just showing you it in a different way. I will put this negative sign here now. Okay, it should not cause any problem. Let's check whether we can end up getting any solution or not. So now let's do this. D psi dy is equal to 2xy. So from here I can write integration of d psi is equal to integration of 2xy dy, right? So dy. So now psi will be equal to what? 2x y square by 2, 2x y square by 2 plus a constant of integration, and that should be x, because you have done the integration with respect to y, right? We have integrated this equation with respect to y. So the constant of integration will be of function x. In the previous case, we had already seen that, right? If you were integrating with respect to y, see, we were integrating it with respect to y, and we got a constant of integration, and that was a function of x. Now in this case, it is the same, 2x into y square by 2 plus f of x. So this is the constant of integration, and from u equal to 2xy, we have done what? In this case, we have integrating with respect to y, right? I'm just doing this, then I have got this, and then I can just simplify it further. Psi is equal to 2 and 2 will be cancelled, so I will be left with xy square plus a function of x. Okay, so this is the function, and now I am required to find the value of this f of x. If I can get this value, I can get the stream function, right? So for that particular reason, I will be doing something like, see, from V is also given, right? V is given as a square plus x square minus y square, right? X square minus y square. Okay, so this is the value for V, and I'm just going to put this value in the equation. Negative d psi dx is equal to a square plus x square minus y square. According to the equation, you can see that the value of V can be written as like this. Okay, so I've just done that and put the value of V. Now what I can do is I can just separately can get d psi dx, that will give me negative a square plus x square minus y square, and I will be left with negative a square negative x square plus y square. And now that I have already found the value of d psi dx from V, I can very easily figure out the value of from this equation. You can say this is my star, okay, and from star you can say star psi was equal to what? Xy square plus a function of x, right? So if I do a differentiation of this with respect to x, what I'm going to get is d psi dx, isn't it? D psi dx, and it will be equal to what? If you do a derivation or differentiation, then you will get y square plus, it is further differentiation will give you f prime x, right? Differentiation of fx gives you what? It gives you f prime x, right? So you can use this. Then as you have already have the value of d psi dx from here, you can put this value negative a square minus x square plus y square is equal to y square plus f prime x. From here you are actually required to find the value of f of x, right? So already f prime x is there, so you need to do an integration here. So y square will be cancelled from both the sides, and they will only be left with f prime x. Sorry, write it like this: f prime x is equal to what? Minus a square minus x square, right? Now f of x, it means f of x means integration in this step will actually give you f of x, right? If you do integration of f prime x, it will be f of x if you are doing an integration, right? Okay, so this is what I have done here, and the integration of negative a square. So with respect to x, of course, because the variable is x, so negative a square into x minus x cube over 3, right? I have done integration with respect to x, right? So this just gave me the value for f of x. So now I'm happy that I have got f of x. I can just put this here to get my stream function. So my stream function is equal to what? From here you can see from the star equation xy square plus f of x, I can write xy square plus f of x, and using some tricks I have found the value of f of x as well. So that will be xy square plus f of x as minus a square x minus x cube over 3, and this is the value for psi, and this certainly is my answer.